Well, review time. What we have here is a Rigol DS1104 or 1104. This is Rigol's new, basically inexpensive scope series. This is 4-channel, 100 megahertz, 1 gig sample per second. Though that is, I believe, there's only one ADC in here, so you can do 1 channel at a gig sample per second, 2 channels at 500 megasamples per second, or 4 channels at 250 megasamples per second. So reasonable bandwidth with 4 channels is probably in the range of 50 megahertz, something around there. I bought this for work because basically I've been using this ancient, really rather decrepit Hewlett-Packard DSO that works but is just a pain in the butt to deal with, and it has a green screen and it's not very fun. And I managed to convince my boss to buy an inexpensive scope, and since most of the stuff I deal with is in the 20-30 megahertz and down regime, generally serial protocol, stuff like that, in a few megahertz or lower, I think this is fine. Screen-wise, it's actually the same resolution as my 4014. The screen is physically smaller, though. If I hold the two up, it's not that dramatic of a difference. The resolution is the same, so again, kind of depending if you, I don't think of it as really being any different. If you have issues with, if you need a bigger screen, you need glasses, etc., it would probably be more of a dramatic benefit. One of the nice things is clicky power button. It actually turns on and off, I would imagine. It feels really solid. This thing's quite heavy. It weighs, I don't know how much it weighs, but it's very, holding it out like that actually takes effort. There's a lot of stuff in here, if nothing else. So in any event, what I'm going to do is we will take a look, and I'll actually insert, it's obviously open, but I'll show you what's in the box right here. Okay, let's see what we get. So, first things first, Rigol love their box in a box. So here is the scope. So we have power cable, nice little protective condom on there, certificate cal and manuals, and then I would imagine we have some inexpensive scope probes. These actually look a lot like the cheap, inexpensive probes you can get for really peanuts from wherever, though it looks like in these situations they're actually Rigol branded. And then it appears the only thing remaining in the box is the actual scope. Wait. This is a USB A to B cable. So let's have a look at the DS1000Z. Or actually, this is a DS1104Z. So, first thing that's readily apparent is this is quite compact, especially compared to the DS4000 which I have. It feels quite hefty. It's definitely got a nice heft to it. So I did not get the one with an arbitrary waveform generator on it because I don't personally think that's too useful. Basically, for the amount of money you spend on the arbitrary waveform generator, you can buy an inexpensive, DDS synthesizer, and I think that's probably far more useful, particularly since it has a separate, its own user interface. So in any event, back panel has LXI, USB, and trigger out. So if you buy this with the 2-channel signal generator, you have signal generator out 1 and 2 on the back, which is also rather awkward, which is one of the reasons I also didn't go for that. Interestingly enough, this actually apparently supports picked bridge, which means I believe you can plug it directly into certain Canon cameras and it'll print to them directly. I don't necessarily know if I think that's useful, but it does. Serial number, blah. 50 watts, 250 volts, 100 to 240 volts, general. So, front panel. So definitely a lot fewer knobs than, you know, the other ones. We have only a single channel control knob. We only have a single channel control knob, and then you select the channel relevant. Horizontal has its own knobs at least. This one does not. It looks like the small knobs on this do not have detents. They're just free spinning, which, never mind, it's the same as on the 4000. I just didn't remember that off the top of my head. The trigger, you know, some of this control panel cluster here is very much in line with my 4000 series. Measure, cursor, acquire, display, storage, and utility. These three buttons are matched exactly. There is no record button, which is here. The help is now here. And then on the Rigol, the 4000, there is a separate default button, and then there is the print button is common as well. So in any event, you know, you have cursor keys here. This is actually quite interesting. So on the 4000 series, you have your 6 keys, and then there's an up and down button at the bottom and a menu key at the top, much like on this side. So basically this control panel is replicated on this control panel on the DS4000 series, but on this they seem to have different, which is intriguing. One thing you might notice is there is no you know, place for the probes to plug in, where, you know, like on the 4000 series probes they use it's not going to focus. Hang on, let me fetch this off. They have a little pin that contacts the front panel of the scope and basically informs the scope of the type of probe, and assuming they're using Rigol probes in any event. Whereas that is not present here, so the scope, you know, if you want to go 1x, 10x, you're going to have to swap manually in the software somewhere. Cal output, USB, other than that it's very similar. Ooh, that's nice. So the power button on this is a nice, that's a clicky power button. I bet that's actually cutting out, disconnecting the power entirely. It's not a soft power system, much like the Rigol 4000 series is. It feels like they have the glass. Yeah, I think they one of the things they did on the 4000 series that I was quite happy with is they use an actual sheet of glass in front of the display just to kind of protect it from fingers, you know, poking and so forth. And it seems, from the, you know, just the way it feels, like the conductivity that they've done that on this as well. Let me hang this probe back up. So you can see obviously some of these buttons here will light up, and then it looks like, it's hard to make out, but I believe there are 3 illuminated buttons there, and then you obviously have run, stop, signal, blah, 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 etc. So that seems to be kind of the brief overview. Let me apply power and we will see what it looks like. Unfortunately, I don't have the facilities needed to do bandwidth testing, but I really don't have the kit needed to do that. You know, I just don't have access to it. I don't have like a really nice synthesized signal generator, or even just a signal generator that'll go high enough that I can really accurately measure 3 dB points. I have, you know, I can borrow some RF generators from work, but they're not flat. So therefore, the real issue is, where am I getting, you know, where is my attenuation coming from? Is it coming from my signal generator? You know, is it coming from, excuse me, is it coming from the actual scope, or is it gain variation in the signal generator, which means I can't really measure the roll-off because, again, there's multiple factors which contribute, and I therefore don't really feel confident putting on a number. But, I mean, I think the critical thing is just, how does it feel to use? I mean, obviously the restricted UI, you know, the fact that you only have one vertical control is going to make it, you know, feel different. I don't think it's going to be that big of a deal. The scope it's replacing uses a similar mechanism, so, and I don't have any trouble with that. The real complaint I have about that is just that it's slow. Though it's actually it's replacing a scope that has a similar sample rate, though I think it has 4K points memory. It's from the late 80s or 90s. One of the nice things, the reasons why maybe these are good, is the hacks, the firmware hacks, or well, not the firmware hack, the QGen hack that lets you run, you know, basically unlock a lot of the firmware options for these, or for the 4000 series, also works on this. So therefore, this comes by default with 12 megapoints of memory, and you can unlock or go turn on, after they've disabled it intentionally, the other 12 megapoints and get 24 megapoints, or all the protocol decoders basically for free. I wonder whether, what Rigol's actual reaction on that is, because I would imagine that, like if I had, $2,000, or $2,500, and I was comparing between, like, say, a 4014 and, the equivalent Agilent, I would probably go for the Agilent if, if the firmware, there was no ability to unlock the protocol decoders. But because I know I can get the protocol decoders unlocked on the Rigol, whereas on the Agilent, I don't believe anyone has it really successfully hacked, though, again, I don't really know. I'm not too aware. I don't have any Agilents. I've just seen them, and I'm like, oh, it's so pretty. Basically, I know the Rigol basically kind of comes stock with all the firmware decoders and so many, all the memory unlocks and all that crap. It makes me a lot more inclined to go for the Rigol scope, simply because basically for the investment, assuming you're not like in a corporate structure where they want legitimate keys, it's much more bang for your buck. So I kind of suspect Rigol is kind of continuing to put out products with their kind of poorly designed, key generation system, simply because they realize that the fact that hobbyists can buy their inexpensive models and make them more capable means they're much more desirable. I mean, it basically means that I think this scope compares fairly well to an Agilent scope with maybe 4K rather than 2K, simply because to buy an Agilent scope with the equivalent protocol decoders and sample rate costs about $4,000. So then the real issue is how much, or something like that. I actually don't know how much the protocol decoders for the Agilent cost, but it's a lot. They're hideously expensive. So the issue is how much more am I willing to pay for the slightly more or the even possibly dramatically more responsive controls. And in this situation, obviously, not that much. Particularly since Agilent has no reasonable entry-level devices. I mean, this was, I think, around $900. And, 250 megasamples per second, 4 channel, 1 gigasample per second, 1 channel. I think it's like more than 1,000 waveforms a second. It's not great. The waveforms per second on this are not really spectacular. The 4014 blows it out of the water, but it also costs 2.5 times as much. But just there's nothing really else in the market space, especially with the fact that this now has the Ultravision, which is the Infinivision knockoff. Basically, it has intensity grading, which now that I've used a scope that has intensity grading, I don't really think I could ever really reasonably even look at going back to a scope that doesn't have it, because I find it so beneficial. I think, unless Agilent moves into, aggressively moves into like the, the $800-900 scope space. I mean, it seems like right now, if you want a 2-channel scope, you'd probably go for a DS2000 series, because I think they're probably a bit more performant. But I really tend to find 4 channels useful, so therefore, if I have to go between, my choices are kind of the 4000 series and the 1000 series. As far as I know, the 2000 series doesn't have any 4-channel scopes. So I probably insert stuff here to show that I'm wrong. I haven't done my homework, obviously, or, well, I did my homework and then forgot it. Just at the price point, it's so much better than, the alternatives on the market. In any event, let's power it up and see how it works. The power cord plugs in the back. It's got the usual warranty void if removed sticker, blah blah blah. I'm going to do a teardown. This one has just 2 little flimsy little flip-up feet down here for angled display. So let's see how it works. Oh yeah, lots of LEDs. This is actually the first time I've ever turned this on. So it definitely has a fairly noisy fan. Air appears to be flowing this way in the chassis, because I can feel intake here and I can definitely feel air coming out here. Not as bad as the 4000 series. Oh, that's adorable. So there we are. It looks like we are now running. Anyways, the menu, it's quite interesting. The menu is much more rectilinear than on the 4000 series. It looks like they've kind of revamped their UI look in any event. It's in auto mode. Where is... Huh. Okay, well that was kind of strange. There's our intensity grading adjustment knob. center that. That looks like I know his floor. This is only, it's 10 millivolts per div, unfortunately. It doesn't go down to 1 millivolt per div. So there is our normal, and this is with, you know, kind of triggering off the garbage. So, in any event. So that's interesting. It looks like now so they're both now running fine. I'm not entirely certain. Actually, so one thing about Rigol scopes that's interesting, useful to know is that their responsiveness goes up dramatically if you stop them. So I mean, it's kind of that's interesting. I mean, seems like it kind of overshoots. I guess it just doesn't like you cranking the encoders too fast. It wouldn't be the only scope I've seen that has issues with that. So one thing you can obviously see is down here we have which of the various channels the knobs currently operate, and that's a pretty nice way of doing it. I wish they had a way to set the colors, because as you can see, light blue and dark blue is kind of annoying. I would definitely be happy with like a green or, you know, some other colors like a red. There's no red trace. What the hell? Well, first of all, my channels are set. Oops, I just turned that off. So what? Oh, I think I'm in high precision mode somehow? Yeah, I was. So there we go. So that's our traditional, I mean, it looks like there's a little bit of static negative DC offset on all the channels. And that was interesting. So, obviously there's some interesting coupling coming on here, which does not surprise me at all. Kind of see if I go like that, as I then touch the ground better. So I'm coupling in, which isn't surprising. I'm not entirely certain why it was railed when it started up like that. One thing that's interesting is it looks like these menus they don't hide. And one of the things I know people were discussing on the internet is that the horizontal divisions here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 horizontal divisions. And I know that I believe the discussion is the DS4000 series has 14 horizontal divisions, which seems to be, I believe, basically a software kind of GUI restriction, which is a little annoying. So you get a little less effective horizontal resolution. Anyways, let's look at. So our time base has. Okay, one thing that's nice is they have the roll mode. So one thing that's interesting is I have found the roll mode tremendously beneficial in, you know, for debugging anything that happens like in the same time scales of human interaction, you know, or things that are, you know, fairly long duration and you're trying to kind of get an immediate feedback. Like, you know, I do deal with some stuff where I have like 1 or 2 packets a second, and the ability to, you know, kind of visualize data flow over many seconds in a continuous manner, rather than the kind of the discrete sampling manner of a traditional scope where you sample a bunch of data and then it's displayed, and then you sample a bunch more data and then it's displayed. To be enormously useful, you know. So I actually use the roll mode quite a bit, and the fact that they have it on this is very nice. They also have YT, which is just traditional XY mode, or excuse me, XY, and then they have 2 YT. Lots of little relay clickety clicks. We have math, blah blah blah, scale options, you know, start, blah blah blah, you know, obvious weird typical menu structure of theirs. So it looks like it comes with the decodes by default. What kind of decoders do we have? Parallel, RS-232, I2C, and SPI. It's not a lot, but SPI and 232 and I2C are basically the big 3. So the fact that you have those, and the parallel decoder, I don't know if anyone ever uses those. But it's there in any event, so you can set your clock, you know, blah blah blah. That's threshold set, format ASCII. channel, you know, blah, bit X, you know, event table. That's always useful. That kind of shows you a table of the transactions rather than trying to view it in the little funky online display. Order export. Oh, that's cool. Look, it can actually dump transaction logs over a bus to SPI. So reference. I don't know what this. That's interesting. Reference channel. I'm honestly not entirely certain what this is. Obviously I haven't read the manual. I wonder if this is possibly related to. Well, no. I mean, you can see there's a little thingy there. It'll be interesting to kind of look into. Measurements. We can turn on the trigger counter. I like having that on. It's useful. You know, measurement source. So going on, here's the acquire menu. One thing that's interesting is we now have the ability to explicitly turn on and off SynX over X interpolation. Memory depth, we have, because again, 4-channel mode, we have 0, 3, 6. So I think it has 24 megapoints of memory in total. Maybe I don't have the memory install right now. Anti-aliasing, you can turn it on and off. In my experience, that slows down the frame rate, makes the display look a little prettier, not perceptibly prettier, so I haven't bothered with it. Storage menu is very similar. You know, this is basically the you know, cut and paste from the other ones. Go look at the Rigol 4000 series review. Intensity grading, you know, blah 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 blah. Well, that's grid intensity. I like a nice bright grid. Persistence time, it'd be cool. I wonder if you can turn. Actually, that would be useful. Which is what the hell is that? Can I turn, or does infinite persistence in XY mode work? So that's annoying. Yeah, one thing I really would like. Oh, that's quite cool. Look at that. We have a scope view and an XY view. And you can actually, the reason it jerks out like that for a second is because it's not auto triggering. So if I crank the trigger way the hell out of the way, it'll live in. Actually, it looks like it is triggering. Yeah, it's shifting to triggered mode. You can see up here. So, let's go into trigger mode. Just put it on AC. That'll work. Yeah, so you can see now it doesn't matter anymore because it's not falling out of trigger. So that was the source of that problem. That's interesting. Look at that. It had to turn on one of the channels to sample. I wonder if we're seeing some of the quantization stuff going on, because you can see how there's kind of like square looking pixels. I wonder if that's quantization noise. It's possible. But one of the things that I would find useful for this sort of thing is like using it as a curve tracer, and that's only really viable if you can do long-term persistence, which is something that they don't seem to allow you to do. In other words, basically I want a continuous scatter plot, you know, so I can sweep 2 parameter channels and basically get, you know, an XY vector display, and I don't see any way to do that. I suppose you could probably just turn down the duration and then take a single sweep of the entire, the entire thing. Ooh, that's interesting. I think I've made it sick. Minor bugs ahoy. I don't know why it's showing 4 separate points. I also don't know why they're all yellow when I'm using a blue and a yellow plot. It looks like there's several floating around. Like, why is there a, like, kind of a railed value there? In any event, that's kind of intriguing. So it looks like I'm in probe mode here, so we have DC, AC, and ground. Bandwidth limit is off in 20 megahertz. Probe is 10x. Nice assortment of probe options. Invert, blah blah blah. Volts per division. Unit is in. That's interesting. So you can probably do other calculations. You can have watts, amps, volts, or I don't actually know what U is. I think that might just be a nameless constant. Delay calibration and the label. Oh, that's nice. So it looks like you can. Yeah, look at that. You can add a nice label, so you can make, extremely pretty. Oh, hey, look, they have templates. You can make pretty print display stuff for there if you're so inclined. Triggering, we have edge, pulse. And it looks like they've got basically the same same kind of trigger options from the 4000 series. Actually, this is pretty cool. Setup and hold. I don't actually know exactly what that would do. Let's look at the help system. That is not helpful. So their help system is without help. Let's go back to XY mode. Or, yeah, excuse me, normal mode. Fire up the run. Utility. I/O setting, what is that? LAN, USB, GPIB. I guess it emulates USB over GPIB, or there's a GPIB option that I don't have installed. I'm not entirely certain. That was interesting. Look at that. So the maximum value is apparently 1 through 30, and somehow it was set to 227. So it seems to me like it's entirely possible this thing came with bum values, or like the flash or the whatever was fucked up internally somewhere, which is kind of interesting. Let's look in the system info. So there you go. Version is 0.02.00.sp1. Vertical I don't actually know what that does. Power set. Default. Oh, I see. Default or last. I like it on last because then it just basically resumes wherever it was. Self-cal options. Installed. So I have lots of trials. Oh, I see. So it's 20. It has 24 megapoints total. 12 megapoints in 2 channels, 6 megapoints in 3. I wonder what it falls back to when that runs out. So there's obviously, oh, that's interesting. Some of these are also trigger trials. Run, window, nth edge, delay, timeout, RS-232, I2C, SPI. The decoders are in trial. Record, replay is also in trial. Lots of trials. Setup, editor off on. That's annoying. So once that, it seems like once you open that up, it's kind of like a, oh, I guess it goes away. And there's the annoying keypad. The painful entering. Aux out is trigger out and pass fail. Auto options, peak to peak, on off, channel all, auto menu, overlay. I don't know exactly what that is. Coupling on. key locker. I don't know what that does. Well, I would assume. Yeah, that basically prevents the other keys from doing anything. Except when you hit that one, I guess. I wonder what use that would be. Print key doesn't do anything. No USB disk. You know, normal rest of the menu options are pretty banal. You have your typical trigger, cluster, mode, menu, and force. And we've already looked in the menu, which is just, you know, there we are. Sweep is normal, auto, and single. Setting, hold off, yeah, look there, noise rejection, interesting. To the end of that. So it looks like we have kind of the traditional, you know, yeah, there you go. So there's your you know, peak to peak, and, you know, etc., etc. You can kind of see here area. And that's interesting. I have quite a few little interesting measurements. So they have 2 pages of measurements there, and 2 pages of horizontal. Oh, that's cute. Look, there's a little dot there, which shows you which menu page you're on. Oh, that's actually, there's one over here as well. That's cute. So that's like a nice little menu cue to show you, you know, how many pages you have to scroll. Let's see if I can find. There we go. So yeah, you can see here. So now that we have 3 menu pages, there's 3 little dots. I wish they made that a little more apparent, but it's once you figure out what it does. You know, they could have made that take up a much wider section. But the fact that it's there, and that's how, the fact that I now know how it works, is plenty for me. So, one of the nice things about the fact that this is, well, actually, I believe, oh, of course, so yeah, it just fell back to 500 megasamples per second, because I believe I'm triggering on the wrong, I'm triggering on channel 2, because I have a clock source. Let's set the trigger to edge. So I'm now going 1 gigasample per second. Turn on channel 4, 500 megasample per second. Turn on channel 3, 500 megasample per second. Turn on channel 2, 500 megasample per second. So since we have one shared ADC, one of the nice things is obviously that it can do any arbitrary combination of channels, you know, and still achieve, you know, its theoretical sampling rates. Whereas with like the DS4000 series, you know, if you want, you have a separate ADC for channel, you know, 1 and 2, and a separate ADC for channel 3 and 4. So your max sample rates are 1 and 4, you know, one of these pair. So the pairs are configurable, though you always have your sample rate loss. Let's see. Yeah, it's a hard power switch. So that's nice. I wonder, the power switch just straight up kills it. Oh, that's interesting. Look here too. There's obviously button options here that are not installed. Did you see that? So watch this space. See? There's a button here and a button here, and I can even feel it in the sticker. There's a hole there. I wonder what options those are. I guess there's a different scope. Oh, I know, of course, what they are. Those are for the signal generator. So when you get the signal generator option, the buttons are here and they have a different label. There's our boot up. It's kind of got this cute progress bar thing. It lights up the various things in sequence. And I guess now it's running, and now it's just like, I'll get there in a second. So we definitely get the nice intensity grading. You can kind of see it there. You can kind of rail it up. It actually looks like this goes a little brighter than the 4000, which I like. But yeah, so I mean, on the whole, it seems, I don't know why the storage menu comes up by default. One thing I'm kind of used to being able to hide these menus, and I guess that's how they're getting away with the smaller, you know, displayed area, is just by shoving menus on you. It seems like it should come up with like the channel 1 menu by default. I wonder why it comes up with a storage menu. And whatever, that's a minor complaint. Yeah, so let's do some actual testing. So moving on, yeah, I now have 2. This one's mine. I brought this into work, where I work, because I needed to do some kind of obscure, you know, anti-phase with dead time duty cycle generation, and my boss saw it and was like, hey, that's pretty cool, buy one of those for us. So now we have one for work and one for home. So this is actually my works, as is the scope, but I stole it for the time being because one of the convenient things about these is they'll actually do a frequency counter, and I'm going to abuse that functionality to do waveforms per second measurements because it's convenient. Yeah, I mean, you have channel 2 count, so I can just pipe the trigger into one of these and use the counter functionality. So anyways, let's get all wired up. Oops. Oh, that happened. It just randomly found itself, I guess. Weird. I wonder if there's like some sort of capacitor that has to charge up on the input front end or something. So anyways, there we go. How am I going to turn it on? So that looks pretty nice to me. So, alright. So, yep. Alright, so let's see, why is my trigger? So you can see the kind of some of this jittery structure in here, and I strongly suspect that if I go in and I turn on anti-aliasing, it will fix that. So that, I think, is much more... I suspect that the anti-aliasing is more along the lines of how the intensity grading works, and it actually does seem like it has a fairly strong effect on the kind of the functionality of the intensity grading. So that may actually be worth re-examining. It seems like it does more than I thought it did. I also haven't thought about it that much, to be honest. So there's the noise signal from the sigilant generators, which is incidentally one of the things I really like about them. So I am AC coupled, I assume. Yep. So there's just a pulse, a 1.6 microsecond pulse, actually. There you go. So you can actually see here some DDS jitter, which is quite cool. But you can also really... I love intensity grading. Wait, have I gushed about it enough yet? I don't know the menus. Yeah, wow, look at how intensity grading helps there. Huh. I figure. I wonder exactly how that works. So I'm playing with pulse modes. That's interesting. It looks like it kind of glitched the background. Oh, I see what's going on. So I actually have signals. They're just hidden by the fact that the pulses are extremely short duration. Yeah. Yeah, so that's a single sign pulse every millisecond. It's a 600 kilohertz pulse. Num cycle. There we go. So there's a nice two cycle sine wave, just gated 2 cycle sine wave. This actually it seems slightly peppier than the 4014 though. I'm not doing a direct comparison. Let me see. I would like to do like an AM modulated. Oh, there we are. So here is a it actually looks like we're having aliasing. How does it get? How did it get turned off? I'm not entirely certain. So yeah, there's kind of your traditional, you know, what is an AM sine wave. So this is a 600 kilohertz sine wave modulated with 100 hertz sine wave. And you know what? I'm just gonna go like this. So I'm now going to turn this on, and channel 2 will be a 100 hertz square wave, and then we'll just go into trigger mode and just tie that to channel 2. Go back up to the edge and run it. What did I just do? I just wasn't triggering. So actually, right now the issue is that that is anyway, blah. I'm getting distracted. So you can see there's a nice AM modulated sine wave. Let's see if I can change the waveform on that. Type shape. Ooh, that's interesting. So that is an amplitude modulated square wave. So you can see if we zoom in, it gets kind of garbagey. And also the downside is we're only triggering at 100 hertz because that's what my trigger input is. So actually, if I go like, put it in normal mode, run it, and then disconnect this. Yeah, so there's a much kind of more random. You can see lots of intermodulation and beating. That's quite interesting. You can also see overshoot. Tie this back in. So you can obviously see the two are not frequency locked together, which is not surprising. But I mean, here's basically the value. You can see that I have these are beating against each other somewhat. I could probably turn on, actually, that would probably help, which is to go down here. Oh hey, this doesn't have, there's no 50 ohm termination option here. That's quite interesting. Possibly worth considering. So let's make the, there we go, that's interesting. So I can just change some of my parameters. Ramp down, modulated with noise, modulated with the sawtooth, modulated with the sine, square wave, triangle. So, so I think I can also, yeah, I can adjust the modulation strength. So yeah, anyways, I mean, you can see the value of intensity grading. I'm just kind of waffling on at this point. So on the whole, it seems like, for the money, I mean, it seems like it's quite performant. You know, again, if you don't need 4 channels, I think the 2000 series might be kind of an inexpensive upgrade that gives you a lot more performance, but considering you get the same resolution screen as you do, you know, even on the DS4000 series, so you're not actually getting any more visual information. The fact that it seems to have LXI and, you know, all of the various interfaces, not the high sample rate. It's not really something that I'm too worried about. And it seems like there's certainly some cranky firmware issues at this point, which I wonder if there's any updates. I think maybe it'd probably be, I think maybe if these mature a little bit, they're definitely worth jumping on. I think it'll do what I want it to do. Yeah, let's see if so I'm not entirely certain what really anti-aliasing is doing. Because it seems like it's not completely fixing the aliasing, it's just modifying how it's displayed. But, okay, wait a sec. So here's obviously the two scopes next to each other, and I figure we'll do kind of a more in-depth, you know, compare and contrast. So, you know, the obvious thing, I mean, the most obvious difference is the fact that you have the segmented memory control kind of knob cluster on the 4000 series, which is also on the 2000 series, and you do not have that on the 1000, the 1104. So what that is the segmented memory lets you basically break up your, you know, however many megapoints of memory you have in total into smaller subsections and acquire, you know, separate short duration events that are with, you know, wide quiescent periods in between. So you can basically sample, you know, say 1 megapoint and then wait, say, you know, the equivalent of 50 megapoints and then take another 1 megapoint sample, and you can do that until your memory is full, which is extremely useful in situations where you have, like, say, a bus which has, you know, data traffic on it, and you have maybe 1 packet a second, and that packet is only a millisecond long, but you need to capture, say, 30, 20, you know, 10 minutes worth of packets. You know, and in that situation, you use, you know, a small amount of memory. You know, in this situation with the 4000 series, it actually has over 100 megapoints of memory. It's something ridiculous. I don't remember it exactly off the top of my head. But in that situation, you can then break that up, and you can take like say like a 50,000 megapoint, or sorry, 50,000 point sample once a second for an hour, probably something like that. And, you know, basically, and then you can kind of zoom through them with the various little, you know, the controls. So that facility is just entirely not present at all on the 1000 series. Depends on what you do. Honestly, I have, in, you know, kind of a lot of the digital debugging stuff I've been dealing with, I've actually not even needed the segmented memory. It strikes me as one of those things where there's one or two situations where it's extremely, amazingly, awesomely useful. And if you don't encounter those particular situations, you never need it. So again, it's you know, kind of very, it has a limited domain, but within that limited domain, it is, you know, basically enormously useful. You know, otherwise you can see, you know, basically the actual interfaces are extremely similar. You know, they've gone for the same color scheme everywhere, which is kind of nice. You can see here's the like the connection, and there's the detector pad for the probes, as I think I was discussing earlier. Where is the probe I took down? Here it is. So you can see these probes have a little metal pin, and that contacts this gold-plated area surrounding the BNC connector, and that actually, you know, I'm not too sure. I think there's a resistor in here. And the scope actually measures that resistance, and then it goes, I plug this in, and it automatically sets this channel to, say, 10x, which is convenient. You know, the downside, of course, is that in this, at least in the context of these probes are 10x only, whereas with the probes the 1000 came with, they're actually 1x/10x, which is actually, you know, it can be useful if you're trying to look at very small signals. Like, I do a fair amount of analog stuff, And 10x probes really just don't work at all for analog stuff, simply because, well, in a lot of it, in many situations, 10x probes are less useful for analog stuff because your actual frequencies, the frequencies of the signals you're looking at are fairly low, so you don't need the 10x probe to get, because you need 10x probes generally because they perform better at, 10, 20, 100 megahertz, something like that. So if I'm working at 5 kilohertz, I don't need the frequency benefit of a 10x probe, whereas I really having the additional vertical resolution simply because you're not dividing your signal by 10 before it goes into the, basically the fixed noise front end of the scope. So a lot of the times I actually just use straight up BNC connection straight into the scope. And the nice thing about having, the auto setting probes is I can disconnect the probe and it automatically resets to 1x because it just, that's what I set it to, and then if I plug the probe back in, it jumps back to 10x. So you have to manage that manually on here, which is a little entertaining. You can see here there's the up and down buttons, which I was talking about, which are both on the bottom on this. You have the additional menu button here. So you can see this, the kind of the size difference of the screen. Again, same resolution. So you're actually getting the same amount of pixel data on this screen as on this screen. You simply, with this, you just have slightly less. The menus don't pop out of the way, so you lose 2 vertical divisions. So, other stuff. Most of the fan noise right now is my computer. Fairly quiet. I mean, you can hear it, but it's fairly quiet. Way noisier. It also has like way more airflow. Like there's so much airflow coming out of here, whereas this is, I can feel it, but it's not too significant. Also, interestingly enough, this has the fancy little loading thing, whereas this just... So it actually seems like this... Their boot rate is about the same, actually, from the look of it. So, you can see here, I have channel 1 and I have channel 3 on. I like this style button better than this style with just the illuminated lettering. These are much less noticeable. It's doing the weird... That's really kind of problematic, actually. Let me turn on... Alright. That's the wrong way. So... Well, first of all, you can see I'm actually in the roll mode right now, simply because that was what I was using last. Fuck, now I don't remember where stuff is. Of course it's in here. So, there we go. We have a sine wave. That's interesting. My vertical scale is actually wrong. Probe is... Yeah, so we have a 2 volt, so it's a 4 volt sine wave, which is indeed what I'm putting in. This is really strange. What is going on? Auto detected none. Wow, it's interesting. I wonder if there's a software bug. That's like a game breaker right there, if it doesn't work when you turn it on. Man, I really hope Rigol fixed that. Because aside from this weird issue... Let's just say 100 kilohertz. So actually one of the reasons I'm not really seeing the intensity grading is because I'm taking too many data points. I can go in here and I can set my memory depth to 14 kilopoints. That should crank up my sample rate, and I'm still not really seeing it. I'll go back to auto. Oh wait, there it was. So we're still railed. That's really kind of a bummer. So ground works. So what the hell just came back? That's extremely strange. Oh wait, why is channel 2 on? That's interesting. So auto scale seems to be turning on channel 2 actually. You can probably tell I don't think I've ever used auto scale. I think this was probably the first time I ever actually hit the auto scale button on my 4000 series, just because I don't really see the point. Does that make me a snob? Probably. Oh, that's annoying. Come on, really? So... Oh wait, no, never mind, I'm just being stupid. Yeah, they work the same way. I'm just dumbass. So one thing I notice is, well, first of all, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, whereas 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you definitely have 2 less horizontal divisions here than here. Is that a big deal? I'm not entirely certain. It might be a little awkward. You still have plenty of data points here. I mean, you know, it's worth noting that we're in 2 microseconds per div on both of these, and this one is sampling. Well, oh wait, no. So this is 112 kilopoints and 24 kilopoints, but this one's in 1 gigasample per second. And this one's at 4 gigasamples per second. So not scaling, but pretty freaking close. You can also see I have cursors on here, which I can turn off. Of course, the downside of having the pop-out menus is you always wind up having to like go, oh, no, I want to get the menus out of the way so I can see the edges of the screen. Not the biggest of a deal. The UI is extremely similar. You know, kind of. You know, performance-wise, they feel basically like the same scope, pretty much. Oops, wrong knob. And basically their performance rate is the same. So let's do something which should really be intensity graded. I think I don't have there we go. So they certainly look fairly similar. This one's much brighter. I wonder if that's a setting somewhere. So I can turn aliasing off on there. It's interesting how the aliasing kind of has different effects. This one just basically turns into a solid block, whereas this one I just start seeing like beat frequency, interesting stuff. It's also this one also is taking 56 megapoints of acquisition. So then I can make them look fairly similar. But I wonder if we're starting to actually see like some, you know, some bias in the ADC there. Though I can I see similar lines over here that they're not as bright. Actually, I wonder if I can turn the screen brightness up, because one thing I notice is the screen on this is way brighter than the screen on here. So that's just So that might... Oh. There's display. So that's the... Okay, so now it beeps at me. That's kind of amazing. Which is kind of... I can see that being useful. I don't see any facility. I mean, it wouldn't surprise me if there was a facility for adjusting the actual screen brightness, but I definitely noticed the screen on the 4000 is a lot brighter than the screen on the 1000, and you can see that. I mean, there's a certain amount of, you know, it being off angles. You can kind of see how it changes as I tilt it a little bit, and it's worth noting that the screen here is like so, and the screen here is a little bit cocked back simply because the top of this is not quite flat, and I didn't decide to prop it up. Let's throw on some modulation. The first thing you can obviously see is this one's, because it's only taking 6 megapoints, is running a lot faster than this one, which is taking the full 112 megapoints. I think that's partially because it looks like this one's running a lot faster, but that's, I think, largely because this one's taking far larger memory. Let's see if I can clamp them to the same. I'll set that to 14 megapoints, and I'll set this one to 1.2 will work. Yeah, so so you can see, obviously, they look like they're sampling at about the same rate. Okay. So they look about the same. I'm sure there's some minor... I think this one's taking more data, and therefore it's losing a little bit of this, or it's a little... It's not sampling quite as fast. And actually, that's interesting. This one's running at 50 megasamples a second, and this one's running at 25 megasamples per second. So actually, now that I think about it, I bet if I go to... yeah, see? So it's just an issue of, I think, sample data and some interesting intermodulation effects. Actually, yeah. So I just switched to a square wave. So now we're seeing far fewer points in kind of the middle. And one thing that's interesting is you see the funky, the intermodulation effects with the overshoot seem to occur on both of them now that they're constrained to kind of a similar sample rate. This one's running 125 and that one's running 25, but they're similar. One of the major advantages here should be that if I go like here, since I'm sampling so much faster, I'm now sampling at 2 gigasamples per second, we basically always see the overshoot, which is definitely an advantage of the much deeper sample memory here. Though it's probably worth noting that if I put this in 24 megasamples per second, it gets that as well. So this has enough memory to kind of catch that. And as usual, there's, you know, there's variations just because the intensity is set slightly differently. And it seems to be resolved slightly differently as well. I think there's some screen variation, which is making it hard to do, you know, very effective A-B comparisons. But I can turn aliasing off and it almost looks better on the 4000 and not as good on the... I think the intensity mapping between these two scopes is slightly different, which is interesting. I mean, it seems like I can turn it off and then I can replicate how the other one looks just by adjusting some of the various parameters. But it's kind of intriguing in any event. I'm not entirely certain what's going on there. Oh, hey, that's kind of intriguing. So I think what we're actually seeing here is like a modulated sound. I'm not entirely certain why that's doing that. Um, oh, I think I know what's going on. Yeah, it's because the signal I'm. So this is a stair-step waveform that I'm then modulating. So we're seeing the various stair steps. But in any event, you can kind of see this is why, this is the value of a scope that does intensity grading, in that you can see this structure inside of your waveform. And, kind of for someone who deals with analog stuff, at least, this is, and I'm never going back. uh, like other stuff, math is always kind of interesting. Like, let's turn on, so this is an FFT. So it's actually interesting. I see. So it looks like they have the same options, though I think a lot of them are broken out into separate. Like this has advanced and logic, which look to be a lot of the various parameters that are just directly exposed here. It also seems like the mechanism for displaying the FFT is different. So, display, split, okay. So let's see if I can't replicate these two. Unit dBm, scale, dB, window rectangle, view half. I definitely am missing the little scrolling dot indicators here, because I'm like, I don't know if I have a more window here or not. So it's also interesting that a lot of this seems to be auto set on over here. So 20 dB, and that's 10 dBV. So I think I have to go to VRMS. I'm actually, this one seems to have two options. Oh, that's interesting. So it looks like these buttons actually affect the I mean, I don't know. No, yeah, it's just beating against it somehow. Yeah, I'm not entirely certain. So we have center. We have hertz per div, which is... Oh, I see how this works. So it looks like this one, because they have fewer knobs, they have to expose a lot of these things, whereas on this one it looks like when you're in FFT mode, they're just directly mapped to the various controls. Or somewhat. So that one's on 10 dBV. I don't actually know how that works. Center is 2.5. Center is 2.5. 50 samples a second effective. That maps, and then I think the rest of it is just... So the center here is 2.5 kilohertz. Which is going to be right there. So that looks about the same. I think if I shifted this up, we'd basically see the same thing. So I don't want to do that. I want to be using that, which looks like it's... Yeah, I don't know. It looks in any event, it looks like the performance is fairly similar. And what we're seeing here is this is just kind of the spike up at DC, which is typical of LFTs. You know, so we have decode. You know, so it actually. That's actually. So you actually have to set it to off. So over here, I mean. So other things like here we have this has parallel RS-232, I2C, and SPI. This has parallel RS-232, I2C, SPI, CAN, and FlexRay. CAN can definitely potentially be useful because I'm not entirely certain what FlexRay actually is. I think it's another proprietary bus. But if you need to deal with CAN or FlexRay, you have to go for one of the higher models. You know, both of them seem to have, you know, both of them have 2 decoders, which is nice. So I guess turning the display on is what actually turns the math on. That's kind of confusing. You know, other nice things that other things that are nice about here. One of the things this actually has is 50 ohm input impedance terminators built in. If you want a 50 ohm input impedance on the 1000 series, you have to use like an inline 50 ohm terminator. Rigol sells them. They're hideously expensive. I'd just buy them on eBay or wherever. Trigger clusters are basically identical. This one has an additional 50% button, which could conceivably be convenient. Seems kind of silly. I mean, considering, well, oh, I see how it works. That's interesting. So this actually, the way the 50% works is it actually takes the envelope of the bits on the displayed data and sets the trigger to the exact midpoint of those, whereas pressing the button sets it to just the center of the screen. So if I have, whoops, if my data is offset 50%, we'll find the 50% in there, whereas actually, I guess that's useful in situations where you have AC, you know, you have a large DC coefficient in your data, but okay. Yeah, as many force, blah blah blah. Record on both. Actually, I don't see a record button over here. I think it's been replaced by the. Okay, so yeah, so the record button is a function of the this cluster here, which is, as I said, the segmented memory, where you can kind of see. So I just took, you know, so I have 3 acquisitions because these are large acquisitions. They're 112 megapoints each. So I can kind of scroll through multiple, you know, acquisitions and actually, you know, zoom in. There's what my waveform actually looks like, which is why we're getting that, you know, interesting onion profile drawing thing. But, you know, because this is such a large acquisition, it only could take 3. And you can definitely feel the scope kind of struggling to respond in time, just because it's throwing around so much data. But, you know, I mean, that's one of the areas where I think an adjuvant would really probably be significantly an improvement, simply because you're going to get so much, you know, they have their whole, you know, everything's done in the ASIC as far as I know, though I'd love to try one. Clear, you know, it does what you think it would do. I mean, I'm kind of intrigued by the kind of the perceptive differences in the display. I almost kind of like the fact that these menus are already out. I wish they would put a slightly larger display on this and have the menus always be available, simply because having to flip them open is kind of annoying. You know, really minor quibble. Yeah, I mean, I think that's kind of like the general overview of the differences. One thing that I want to do real quick before this ends is I want to look at the waveforms a second on the 4000 series, just kind of as a contrast. You saw, I think I was able to pull off around 30,000 waveforms a second on the 1000, which is not that bad at all, you know. So let me just hook up a second to measure the waveforms per second on the 4000, and we will look. That's actually a couple of the differences worth noting, where the 1000 series only has the trigger output. The 4000 series actually has optional VGA as well. It's got a USB host on the back as well. It has USB device, which I think Yeah, so the 1000 has LAN, USB device, and trigger out / pass fail out. Whereas the 4000 series has an optional input for a 10 megahertz external reference. It also has VGA. It has an additional USB host. And then it has trig out, cal out, and then I think this is probably also pass fail out. And they're also, the back panel looks kind of different. This one pulls air in here and it blows it out here. This one, it pulls air in here with what looks to be a 60 millimeter fan, and then it gets just vented out this side panel, and it's much less noisy. Again, this one has a hard power switch back here, because this one uses a hard power switch kind of natively. It's just on the front panel and it'll bottom. So, whoops. So that huge number sufficiently caught my attention that I'm now like, I want to look at that on the scope, because I think this thing's only spec'd at 100,000 waveforms a second. So one thing you can see is it's doing this really quite irritating railed thing again. If I go to ground, it fixes it. Though I also don't hear any relays clicking, so I'm not too sure how the couplings are accomplished. Man, that's just unacceptable. Oh, and then suddenly it comes back randomly. That's extremely strange and really kind of horrible, to be honest. So there's my trigger, which, let's see, display. I want measure. Oh, I think I know what's going on. I think it's measuring just the low time. Well, that's annoying. So, looks like it's doing about 91,000 waveforms a second, which is more in line with what I would expect. So, yeah, so I think this is not the brightest, this counter is not the brightest counter. I think it's using just the low time interval, which is kind of annoying. I think I had problems the last time I tried to use it as well. But, yeah, so you can see the trigger, the width of the trigger pulse varies a lot, which is kind of intriguing. But yeah, it definitely looks like this thing is at least managing a good 90,000 waveforms a second without too much effort. See if I can't give it a kick in the ass. That's really interesting in that it's actually slowing down as I crank up the input frequency. It's also possible that counter was counting falling and rising edges. It's just extremely stupid. Alright, let's start. Actually, let's just try like 110 kilohertz. So that's quite intriguing. So suddenly the trigger has decided to invert. Oh, I know what's going on. So the trigger is high going, but what's happening is we're seeing the window between where the next trigger input comes and... Okay, so now we're down to 10 kilohertz. So what happens is... what happened is I accidentally hit... I didn't go to 110, I went to 11. Yeah, so you see now what we're actually looking at is basically the trigger, and then there's the window where it's available. So it looks like there's some interesting jitteriness going on in there. I wonder if that's just like micro performance issues. 20 kilohertz. Yeah, so it looks like the reasonable, real world, achievable waveforms per second on the 4014 is in the realm of about 92,000. I've definitely seen it. I had a similar setup going, and I saw it peak up to above 100,000 before, but you need a really, really specific set of circumstances to do so. Okay, so now that we seem to know that my test setup earlier was stupid, let's just flip scopes and see what we get. There's interesting. Blah, 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 blah. There it is. So, auto triggering. Well, there we go. So it appears if you're not triggering, the auto trigger rate is roughly 40 hertz. But so I'm measuring an input frequency of 1.02 megahertz, which is exactly what I'm putting in. So my trigger rate is still okay. So it looks like the maximum acquisition time with the full 24 megapoint capture width is roughly 40 hertz, which I think is probably what was setting the auto trigger. So now we're down to a it's still saying it's capturing 24 megapoints. Oh, it's because I never set it back to auto. Okay, so now we're doing a 60 point capture, which is pretty miserable, but we are getting 15.24 kilohertz acquisition rate, which is not that bad. I mean, that's fairly, it's... Oh, hey, look at that. So it actually slows down when you go to the really low division. So 60 points is 15 kilohertz. 120 points is 20 kilohertz. 240 points is 22 kilohertz. 600 points is 30 kilohertz. It's actually managing 30,000 waveforms a second, which I think is what I saw earlier, so I guess it kind of was working better there. So above 600 points it begins to slow down again. Now I'm at 1.2 kilopoints and we're only getting 17 kilohertz, 17 kilo waveforms per second. So it looks like this does indeed top out at right around 30,000 waveforms a second. Yeah, so now we're back down to like 3 kilohertz with a 12 kilopoint acquisition. We're getting roughly 2.2 kilohertz, and I probably could tune that a little bit by adjusting this, but I'm currently putting in a 1.250 megahertz square wave, which you can see is a square wave, and actually you can see that the trigger measurement up here is measuring 1.25000 or 1.24999. So it's actually, they match fairly well. It's interesting that the really low point, I mean this is a 60 point acquisition, and it's running slower than the 600 point acquisition, which makes me think this is actually optimized for slightly larger acquisition sizes, which is very nice. That makes me quite happy. But yeah, so it looks like the real world, kind of with a nice high frequency repeating waveform, you actually can get 30,000 waveforms a second out of the 1000 series without a whole lot of effort, which is very nice. So, I mean, I'm now up to well, that's interesting. So now I have a 25. So my input waveform is now 25 megahertz, and I'm only getting 12 kilohertz triggers. and they're speeding up when I go smaller. Now it's 15 kilohertz, 15 kilo waveforms per second at a 60-point acquisition, 18 kilo waveforms per second at a 20-point acquisition, 16 back down to 11. So I wonder why that varies like that. But, you know, there you go, back up to 30 with reasonable waveforms. It's interesting that it varies. So now I'm just a straight 1 megahertz input, and I'm getting 30.3 kilo waveforms per second. So it's interesting that the sample size seems to vary so much. Or the waveforms per second seems to vary dependent on so many different factors. I suspect that like the various sampling windows are beating against each other, which is probably what's leading to that. But in any event, it seems like we can kind of confirm a real-world 30,000 waveforms per second, at least on a square wave, you know, so somewhat synthetic. But I'm actually achieving it rather than simply reading it off the spec script. That'll be interesting. Turning on anti-aliasing. Oh, that's cool. So anti-aliasing doesn't actually seem to cause a performance hit. I wonder if anti-aliasing is happening in the processor after the acquisition front end, which is all in an FPGA. So in any event, 30,000 waveforms per second real world. So what do I think? Oops. So what do I think? The strange behavior on startup where the channels are railed is really kind of unacceptable. They need to fix that. I mean, that's a big deal. That's, you know, or at least we need to know why it's happening, and like if it means the scope needs to sit for a minute when it warms up, that's obnoxious, and they should fix that too. But that's more acceptable than I have something broken. You know, on the whole, for $700, it seems like a very nice scope. You know, I mean, it seems like you get, you know, if your waveforms per second are the metric by which you're going by, 30,000 waveforms per second seems pretty reasonable. Again, you know, this is kind of a synthetic situation, driving with a square wave. It's not something you're going to achieve in the real world. But, you know, I mean, it means you can approach that if you're only getting 10 kilo waveforms per second, and that's still pretty useful. You know, bug hunting, you know, waveforms per second is kind of the critical thing, because that, you know, determines determines basically the amount of time you're actually looking at the signal versus the amount of time the scope is spending thinking, and it means you're more sensitive to, you know, what's going on in your, you know, kind of your waveform. You know, you're more likely to see glitches that are, you know, not very common. You know, intensity grading, you know, basically major selling point. I don't think I'd ever want to work on a scope that doesn't have it anymore. Other than that, you know, I mean, some of the stuff. I mean, it seems like the 12 divisions per, you know, for the screen and the 14 divisions for the screen is very much like it's a difference between the two scopes that is mostly something that it's manufactured. You know, which is a little, it's kind of annoying. I mean, I quite like having the menus out all the time, but, you know, it seems like they could have just compressed the horizontal reticule rather than reduced it, which is annoying. The little dots that indicate where you are in the scroll position, I actually quite like. I wish they had that here, where now they have like a flashing arrow which tells you there's more down, which is a little annoying. One of the things I actually really like is the new buttons, the overall clear buttons with the black text on them that light up. With this scope, I mean, you have basically opaque buttons with light up text, and they're so much harder to see. Like, I don't, you know, like, I have to kind of look and, you know, put your head in the right place to see if I actually have channel 1 on. So I actually often find I'll turn things on and off accidentally. I mean, it's not a big deal, you know, you just press it again, you know, it goes off and on. But, you know, I mean, definitely, like, in the terms of, is this running? I know, is this running? It's harder to tell, because it's, you know, so I really hope they will, you know, steal this button style and put it on, you know, the 4000 series, and then maybe I can buy a replacement button memory. You know, other stuff like the auto probe settings are nice. Depends on whether or not you intend to use 10x probes a lot. I use 10x probes a lot because I have them, not necessarily because they're warranted. You know, and you can always just remember that you have to multiply by 10 in your head, or you can fix it in the scope. Difference is the intensity grading seems to perform pretty similarly on both. It looks different, and the visual differences kind of intrigue me. I'm not entirely certain what the cause for that is. It could just be the slightly different resolution screen. I mean, theoretically, they're both taking the same resolution data, so interesting. I'm not too sure if it's a meaningful delineation. They both have LAN, which is nice, though I found it to be obnoxiously slow, which is kind of a bummer. Also, there's no real good software for it. I've tried that third-party Rigol Ultravision Utilities software and found it to be extremely cranky. And the Rigol software is just terrible as usual. I think it's written in Java, which is enough said. Other than that, I mean, yeah, if you need 4 channels on a budget, I don't think there's any major downsides to the 1000 series. It seems like it's quite performant for what it is, and someone like me who really wants a 4-channel scope, pretty happy with it. Definitely, you probably saw earlier I was having some trouble just relating to the fact that I was expecting this to be the vertical, the horizontal control, just because the muscle memory fucks me up all the time. I have issues with stuff getting into my muscle memory immediately, and obviously having one at work and one at home will probably work better than having them right above each other. But yeah, I mean, I think it seems like it's quite a nice scope. If they can fix the channels being railed at startup, which my assumption would have been there's a sticky relay in there if all of the channels didn't do it. It seems to me kind of like there's a accumulated charge in there, or there's an AC coupling component somewhere that has to charge up to the point where it then begins to properly pass a signal. But I mean, the fact that that's quite interesting, which is that changing the coupling mode does not cause a relay to click in, which is strange because normally that would be a relay clicking in over a capacitor or clicking out over a capacitor. So the fact that that's not there makes me think that the DC versus AC coupling is probably done through analog switches or within a chip. I'm sorry, I'm rather drowsy. Within a chip or something, which makes me think that maybe that's where the issue's coming from, because I believe now that I think about it, actually now that I've tried it, it doesn't click in and out on this one too. So I know there's a commercial PGA front end thing. I think it's from TI that they're using on the front end of the 4000 series, which they may very well be using on the 1000 series. We'll see in the teardown. That may have optional DC versus AC coupling, and that could be where that's coming from. Definitely, I'm probably going to contact tech support about that. It's very strange. And we'll see what they have to say about that. But if they can nail that down, I would say I would give this basically a complete recommendation. Again, you have to weigh your costs and benefits. If you don't want 4 channels specifically, spending a couple $100 more going for the DS2000 series is probably definitely worth your money. You get bigger sample depth, you get the segmented memory, and so forth. I really wanted 4 channels, so my 2 options. I don't believe they have a 4-channel DS2000 series because that would be strange. D2000 kind of 2-channel, it's got 2 in the name. And the 4000 series was just is twice as much money, and you do get better performance, but it's not meaningfully enough better to warrant the upgrade. Again, also you have to evaluate what you need. This is 4 channels at 1 gig sample per second. This is 4 channels at 250 megasamples per second. So is 250 megasamples per second sufficient for your application? For me, yes. For you, maybe not. You have to kind of do some actual deep evaluation. You have to weigh your benefits and your costs and whether or not you can convince your boss to pay for it. So yeah, I mean, so it's a recommendation with the reservation of once they fix the DC offset issues, assuming that I'm not doing something hideously wrong, which I probably am, but that's another affair. So I hope you enjoyed this, and teardown to come.